my screen now?
Yeah.
Okay. So I'm going to talk. Hi everyone. I'm going to talk about our paper, TURJUMAN, a public tool for neural Arabic machine translation. This work is done by Moatez, Billah, Nagoudi, and Abdul-Mageed, and myself, AbdelRahim Elmadany. Yeah, our outline today will talk about what is TURJUMAN is and give a brief background about LREC5, our model, and we'll discuss ARA Opus 20 parallel datasets, and we will talk deeply on TURJUMAN itself about training and evaluation and methodology. So TURJUMAN is a neural machine translation tool. It's based on our LREC5 text-to-text encoder, encoder-decoder transformer. LREC5 was recently released and published with ACL2022. TURJUMAN has ability to translate to any language to MSA. It's one model with multiple inputs with 20 language, and the output is Arabic. And also it supports several encoding methods. We will talk about it quickly. So LREC5, it's encoder-decoder for Arabic text generation. It was trained by 248 gigabyte of text and around 30 billion tokens. It's the paper itself. If you need to discuss more or know more about LREC5, you can easily go to the ACL paper. Okay, and it was improved significantly many of machine translation tasks in many datasets, and also I would perform multiple tasks from many language generation and understanding tasks. Also, LREC5 it's supposed to use or fine-tune with text generation, machine translation, and question answer and paraphrasing, as you see in this figure. So for training TURJUMAN, we create new datasets. It's called ARA Opus 20 parallel datasets. Mainly, it's extracted from Opus data. It contains 20 language, 16 from higher resource language, as you see in the graph, and also it's covered for low resources language. Okay, to select and filter the data from Opus, we ran semantic similarity parallel sentence model. It's the multilingual version of SBERT. Okay, so and also we keep only as a similarity score between two sentences, the target from the multilingual and the Arabic text between 70 and 99%. So we select this range of similarity based on manually checked. The training of data of TURJUMAN is done by 96 GPUs from AMD versions. From it, each GPU has 16 gigabytes. It's as I told you, it's one model with different many to MSA. It's fine-tuned based on LREC5 with this hyperparameters 20 epochs for 20 epochs and with batch size 32. The maximum sequence it has 256 and with learning rate 5E-5. Evaluation, we evaluate TURJUMAN with multiple baselines. We built sequence to sequence as a vanilla version from sequence to sequence transformer. And also we use MT5 and MBART50 many-to-many model. For the final evaluation, we evaluated on the dev and test of ARA Opus 100, Opus 20, and also with the dev and test from United Nations Parallel Corpus. and we use blue score as evaluation metrics. So we select the best epoch based on small diff from our Opus 20. Okay. The results, as you see in this table of on our Opus 20 development and test sets, as you see, TURJUMAN is achieved 13 language achieve outperformance 13 language of 20 on the test of our Opus 20, and also outperform the other baselines. Yeah, as for the sequence to sequence and input, it's giving more outperformance, plus or in average 9 blue scores. However, it's slightly improved than MT5. Okay, so as you see in red circles, it's the T5. It's outperformed TURJUMAN in 7 languages. Okay, so when we are doing some analysis on this language, because this language is not covered by RT5 itself, the vocabulary, because RT5 is built on vocab with 10 language plus Arabic, but it hasn't. This language doesn't cover on the train itself. Okay. For this reason, it doesn't improve in TURJUMAN. I think it needs to be more data. Some of this data, like GD and Tamil and Yoruba, it's very low resources. It doesn't have enough data for train. And also, for example, Korean, it's different. If you see MT5, it's outperformed TURJUMAN more than 5 plus blue score, because also Korean, it doesn't have an RT5 vocab, and it's different scripts from what we have. So for the evaluation on other datasets united parallel corpus, as you see in this figure, RT5, it's outperformed all the baselines. For encoding methods, TURJUMAN has support for our 3 mainly decoding methods: grading search and beam search, and also sampling from Toolkit and Toolkit. So the beam search is default method on the Toolkit, in case if you are don't choose any encoding methods. So this example, as you see, it's translate and showing the translation from English to Arabic with different encoding method or different encoding generation. As you see, the ability of model that can be generate well or present well translation from this English sentence. Okay, so in meanwhile, we are providing the source code from TURJUMAN, and also we provide multiple command line interfaces that to be easy for everyone to translate and evaluate or check the model and use it on his data sets. For example, interactive, it's allow you to write whatever you would like to translate and show you once you hit enter, you get the translation from the 3 targets output. For the interactive, it's for this version of the Toolkit, it only support beam search. However, the translation, the TURJUMAN translate command, it has 2 versions. One accepted input as a text, and also another version is accepted a file if you would like to translate multiple sentences at the same time as a batch. And also the TURJUMAN translated support the all encoding methods and arguments. You would like to try whatever you would like to translate. And also, we provide a score command to easily to compute your blue score between the source, the translated target, and the goal translation. This is a list of these are the list of arguments that are available on TURJUMAN, and it's showing for each command line what is the argument. You can see these arguments on the paper itself and also on our GitHub and follow documentation from the tool. Also, we provide a demo on our website about how you can try TURJUMAN, writing a text, and try different encoding methods and different parameters as you would like to do. You can check it on demo.dnlv.ai/turjuman. Moreover, we provide multiple examples from Collab to use how to use each command line, providing more examples, how to search, how to use different encoding methods, and also providing multiple examples from multiple languages. You can find these examples on our GitHub.
1 minute, Mr. AbdelRahim.
Okay, so for other things, we also provide some examples to how to integrate TURJUMAN with your code and your product if you would like to use it on a research product. Last things, I would like to acknowledge all our supporters and providers, like Elmadany and Shark and Microsoft and AWS and Toolkit Canada. Thank you so much.
Thank you, AbdelRahim. Any question from our side here, remote participant? Please raise your hand. Okay. Mohandes Hamdi, if there is any question from your side. Thank you.
Do you have any question?
Hello, do you hear me now?
Yeah, I'm hearing you now.
Thank you, AbdelRahim. So the enhancement, the benefits of using TURJUMAN is only the performance, the accuracy, the blue score better than the RT5, for example, or we have other benefits like the speed performance or memory utilization or supporting different languages, for example. What are other benefits rather than the blue score? Thank you.
Yeah, yes, thank you, Hamdi, for your question. It's in current version of TURJUMAN, it's supporting multiple languages, about 20. Okay, we are working to enhance the performance as well as. However, we are trying now to improve the weakness from some of low resources by adding new data and training more efficient from this data. Other question?
Okay, thank you, AbdelRahim.
Thank you.
Thank you very much.
No, sorry, there was another question you were looking at. No?
Hello, do you hear us? Hello?
Sorry? Yeah.
Hello?
Yeah, Hamdi, I'm hearing you.
Okay, very
You
good.
have
So-
a question?
Yeah, so the question is about, given the technology you're using, you should be in principle more able to handle text that has code switching between Arabic and English and French and English. I'm wondering if you have done any testing on translation from code switch input or not.
Actually, I can't recognize the voice well, but as I understood from my first impression, it's talking about code switching.
Yes.
I'm right?
Yes.
Yeah. Now for this version, it's not including any code switching, but we are working to add this feature in our future about token level to detect the code switching in Arabic text or translate.
Thank you, AbdelRahim. We need to go to the second paper today with Zain Sheikh Ali, detecting user prone to spread fake news on Arabic Twitter. Would you start, Mr. Zain?
Thank you. Okay, yes, I will start.
Mistake. I'm sorry.
Yes.
Okay.
Okay, let me start sharing my screen.
If somebody wants some water, we can get.
Okay, can you see my PowerPoint now?
Yeah,
Okay,
it's
great.
clear.
Okay, Bismillahirrahmanirrahim. Assalamu alaikum, everyone. My name is Zain Sheikh Ali, and I will be presenting our paper titled Detecting Users Prone to Spread Fake News on Arabic Twitter. This work is a collaboration between me and my supervisors, Dr. Abdul-Aziz Al-Ali and Dr. Tamer Al-Sayed here at Qatar University. Okay, so for this paper for this presentation, I will go through the following outline. I will introduce the problem and I will go through the problem definition. I will cover some related work and then I will list the contributions of this work. Then I will explain the data collection process, how we extracted the features and the features that we selected, our experimental evaluation, the data that we released, and I will conclude finally. Okay, so let me begin with an introduction to this problem. I know maybe most of you are used to fake news detection for maybe tweets or claims, but here in our work, we are targeting the source of the tweet or the user that is tweeting misinformation, because we believe that users do play a critical role in spreading fake news. We classify these users, or we define these users as users that contribute in the diffusion and amplification of fake news, either intentionally or unintentionally. And we believe that if we identify these users, we can help in the mitigation of misinformation spread, and we can also help in early detection of fake news. So our problem is defined as follows. Given a username, or I mean a Twitter user profile with their recent information, such as recent tweets and their profile information, our goal is to detect whether they are prone to spread Arabic fake news or not. We are especially targeting Arabic language in our research. Okay, so there is very few related work on detecting users that are spreading misinformation on Twitter or on social media. But I tried to choose the most relevant papers to summarize them in this slide. So I will start with the most relevant work, which was a shared task at CLAY 2020. In this task, it was an author profiling task, and the goal was to detect if a user is keen to spread fake news or not. So it is a binary classification task, and it is dependent only on the recent 100 tweets of the user. This task was done on English and Spanish, so there were two languages only, and it is worth mentioning that the winning participation in this task has achieved 75% accuracy on English, on the English dataset, and 82% accuracy on the Spanish dataset. Their approach used a stacked ensemble classifier of 5 different machine learning algorithms, and they utilized textual features that are specifically, they are character engrams, in addition to other statistical features that were derived from the text itself. Another work that is also similar to our work, this was proposed by Rath et al. In 2021. The goal of this work is to detect detect misinformation spreaders given a specific tweet and a directed social network. So maybe this approach is a little bit different from the previous approach because it is not dependent on the tweets or the language of the user. Here they are depending on the social network, and I mean the following and followers of a specific user. So it is a graph-based approach. Now that I have talked about related work, I wanted to point out our contributions and how our work is different from other related work. First, we are targeting Arabic language, and we propose the first Arabic dataset for this task. So we propose a dataset of Twitter users, which is a binary dataset with 2 classes. The first class is the positive class, which is users that are prone to spread fake news, and the opposite class is users that are not prone to spread fake news. Second, of course, we propose the first Arabic classification model for this task, and we achieve a F1 score of 73. And finally, we also make our source code and features available, publicly available, to enable reproducibility. So let me quickly go through our data collection process. As I said, we collected a data set of users, but we went through multiple stages before generating this data set. So to identify users that are spreading Arabic misinformation on Twitter, we had to first identify claims or misinformation that exists on Twitter. So our first step was to collect claims. To do so, we utilized 2 Arabic misinformation data sets. The first data set is Arc of Rumors, which is a data set that covers claims that are related to COVID in regarding with multiple topical categories such as entertainment, sport, health, and even political claims. We also used Arafacts, which is our data set, and it is a collection of 5 different Arabic fact-checking websites. We crawled all the claims from these websites, and we collected additional metadata such as the factual label and some more information about each claim. So this is the summary of the collected claims. We have 299 true claims in addition to 5,072 false claims. So after we have collected the claims, we wanted to find the tweets that are related to these claims, that are either supporting or refuting this claim. So the Arc of Rumors dataset, it contains claims that are annotated, that are already annotated if they are supporting or refuting that claim. So we utilized these claims. For Arafacts dataset, we manually collected and annotated tweets related to the claims. And we also collected all the retweets of these tweets. So this is a summary of the statistics, around 2,000 true tweets and 4,493 false tweets. Finally, after collecting all these tweets, we wanted to find the users, of course, which is our main goal. And because we had a very large number of users after collecting the retweets, so we decided to set some filtering criteria, and we removed any user that has less than 1 verified tweet. Here we are eliminating users that have only retweeted any of the verified tweets. So we were only interested in users that have actually shared a tweet or not retweeting it. We also attempted to collect more evidence from the user timelines. So we searched the user timeline for more tweets to find occurrences of verified claims. In total, we have 4,176 unique users. To annotate the users that we have, we set the following criteria. If the user has shared at least two false claims, they are labeled as prone to spread fake news. Otherwise, if they have shared at least one true tweet and no false tweets or retweets, they are not prone to spread fake news. And this is the user statistics. 541 users are the positive class. They are labeled as prone to spread fake news, and the negative class is not prone to spread fake news. And there are around 1,000 users here. So these are the features that we have extracted from each user profile. There are 4 different feature categories. The first feature category is profile features, and these features describe the user profile information, such as the account age, the number of tweets that they have shared, and the ratio of the followers to following. In addition to that, we derived statistical features from the user timeline, and these features describe the user impact and their activity. We also derived emotional signals, and these features are derived from the user tweets. So we use the emotions functionality from the ASAT tool to derive the emotional signals. Finally, we use also textual features, and these are character engrams that were derived from the user's recent tweets. Okay, so I will go through our experimental evaluation. I will first explain the experimental setup, and I will go through the 3 main research questions in our work. So these are the data sets that we have used in our work. First, of course, we used the Arabic data set that we created here. We abbreviated as ARPFN. The second data set that was used was the English data set, which was used in the author profiling task at PAN, where they attempt to find users keen to spread fake news or not. You can see here that the English data set is balanced, whereas the Arabic data set is not balanced. Okay. So for the data split in our experiments, we used 10-fold cross-validation for the Arabic dataset. We similarly also used 10-fold cross-validation for the English dataset, but in order to compare our results with the shared task results, we also used the same split that was used in the shared task, which is a 60% to 40% train test split. To evaluate our results, we used F1 of the positive class, where the positive class is users labeled as prone to spread fake news. And we also did statistical significance test. We performed a 2-tailed paired t-test with 5% level of significance on our cross-validation folds. And this was done in order to find if there is statistical significance in our results in comparison with the baseline score. So the baselines that we have used, I will quickly go through them. First was the majority baseline, which is a classifier that always predicts the majority class here. I mean, it is always labeling 0, for example. The second baseline was the winning participation at the PAN author profiling task. The code was already available, but we did some changes to the code to accommodate Arabic tweets and Arabic language. And we also did a small improvement to the winning participation at PAN. Specifically, we changed the textual features, and we concatenated features with emotional signals, which yielded in better performance. So just to clarify, we will be using this as a baseline in our scores. So this is the baseline that I will be referring to because it is the best one. So I want to start with the first research question that I tried to answer here. So our goal was to classify users, as I said, and we have extracted multiple feature categories. And in this research question, we want to know which feature category combination is optimal to classify the user. So I am showing here the 3 main scores, or the 3 main results, that feature combinations that I have. But of course, in the paper, we have more details and more scores. We have used different machine learning models. We used random forest, XGBoost, logistic regression, and a simple multi-layer perceptron. We abbreviated as neural network NN. So I will go quickly through each graph here. You can see when we use textual features only, and here I mean character engrams of the user's recent 100 tweets, you can see that we are able to outperform the baseline model that I mentioned earlier with simple textual features only and a single machine learning model in comparison with the baseline, which is an ensemble of 4 different models. We can notice here that as you combine more feature combinations, that the performance is improving more and more. And here I want to note that XGBoost and logistic regression and the neural network significantly outperform the baseline model. And finally, here you can see that when we combine all the 4 feature category combinations, we achieve the highest performance, which is 70% F1 score on the XGBoost model. So this is the conclusion for the first research question, that when we combine all feature categories, we will have the best performance. Okay.
Time, please.
Excuse me.
2 minutes.
Yes.
Oh.
Okay. For the second research question here, we want to answer is the second research question that we want to answer is, what is the effect of increasing the number of considered user tweets on the classification performance? So as I said in my previous experiment, I used only 100 recent tweets, and this is the default that was used in the shared task at PAN. So we did the same, but we wanted to explore the effect of increasing the number of tweets. So I selected the best 2 models, which is the XGBoost model and the logistic regression model used here. And I tried different experiments. So the first experiment is when I use only 100 tweets to classify the user. Then we increased the number of tweets to 500, and you can see that performance is slightly better here. After that, we used 2,000 tweets and then 3,200 tweets, which is the maximum number of tweets that I can retrieve from Twitter API. And as we increase the number of tweets, you can see that the performance is also improving. So this was very interesting to note, and especially the logistic regression model here, it achieves 73 F1 score. So this was the highest performance achieved. We also wanted to prove that our methodology is not only effective on Arabic, it is also effective on English. So we used the English dataset that was used in the author profiling task at PAN. Here you can see this was the winning participation, and they achieved an F1 score of 74. But when we applied our method, which is an ensemble of 4 different machine learning models, it is the improved version, as I mentioned earlier, and we combine textual features in addition to emotional signals. We do outperform the performance at the winning participation at PAN, which is the current state of the art. But we also did, we want to note that we did tenfold cross-validation to apply statistical significance test, and it was not statistically significant. But you can tell here that from the same data split, there is a slight improvement. Okay, so for the data release that we have made available, we published the features that we used in our experiments in order to allow for reproducibility. The code also will be available very, very soon. You can access our GitLab page here where the code is available. Of course, in accordance with the Twitter content redistribution policy, we keep all the usernames anonymized. No user information is available. Even the tweet text is not published, so the user privacy is maintained, of course. Okay, so quickly to conclude our work, we explored a very underexplored task in fake news detection, which is identifying users prone to spread fake news. We constructed the first Arabic dataset for this task, and we proposed the first Arabic classifier. Our best model has achieved an F1 score of 73, and we were able to outperform the current state of the art in English, and we achieved 79 F1 score. That's it. If you have any questions, please let me know, and thank you for listening.
Thank you very much, Zain.
Thanks.
Any question from our side here? A remote participant.
Can you hear me? Yeah. Nice work.
and also one of the organizers actually of the.
Excuse me, I can't hear you clearly. Can you please raise your voice?
Yes.
Yes.
Can you hear me now?
It's a little bit. I'll try. It's not very clear.
What about now?
Yes, now it's very clear. Yes.
Great. Okay, nice work. I was saying that I'm Paolo Rosso, one of the organizer of the Sure Task
Yes.
at PAN on fake news spreaders you mentioned.
Yes.
So I appreciate your work. And I was wondering, you mentioned that you, in your approach, you integrated some emotional signal.
Yes.
So I was interested in knowing something more, because in another work, actually, yes, we did something similar on English data, and it seems that it works. And actually, we also took into account personality traits features. So I was wondering if you are interested in also see if this kind of affective and personality features could help in profiling fake news spreaders with Arabic data. Thanks. Shukran.
Yes, thank you, Dr. Paolo. Of course, I tried looking into personality features, and from related work, it seems to be very effective. Unfortunately, there are not tools yet to detect personality features in Arabic, but if there are, of course, I would be interested to try it because it seems to be very useful.
Okay, next question, I guess this is Nizar Habash, New York University of Abu Dhabi. So thank you for this wonderful work and the formulation. The problem is very interesting. I do have a question about a technical aspect of how you set up your experiment. So if I followed you correctly, you had about 4,500 users at one stage, and you applied two rules for selecting who counts as prone to positive, prone to be a true retweeter versus prone to be a rumor spreader. But and then the total number is 1,500. So that means there's 3,000 users, or 2,500, I'm looking at the number right now, who are dropped out of the conversation, right? Like the difference between 4,100 and 1,500. So these are people who are basically the people who will spread some rumors sometimes, but spread some true tweets sometimes. And you don't include them in this, but they're technically the majority. They're twice as many as the people you looked at. From a practical point of view, when I get a tweet from the sea of Twitter, or a user from the sea of Twitter users, I don't know if they're gonna, I mean, they're more likely to belong in this middle group, not in one of the extremes. So how do you approach solving this problem, right? So it may be that you get really relatively good results because you're looking at really extreme cases. What about the people in the middle? How would you approach it? What do you think you would do next? Thank you.
Okay, so users prone to spread fake news, if you can see the slide now, if we look, if they share any false information, regardless of the number of true information that they share. So there are some cases in our data set, and there are some users that have actually both a mix of true and false information. But for the opposite class, there are users that have, or we attempt to find users that only share true tweets and no false. So this class, I mean, if I understood your question correctly, this class, it does include users that have shared both. It is not only the extreme. Yes, I think this is your question.
I'll follow up separately by an email. Sorry about this. I don't want to delay the conversation.
Okay, sure. No problem. Looking forward.